Let's try to solve this problem here. So you have a wall of dimension 4 meter times 7 meter, which consists of 2 layers made of 2 materials X and Y. So to visualize the situation, let me show you something over here. So this, you can think of it like a wall. Okay, so here is 4 meter over here, then it's 7 meter over here. Then they say it consists of 2 layers, right? So means by if you move and look at it from this angle, you can see that there's 2 materials involved. One is material X and one is material Y. Okay, so they tell you that thermal conductivity of Y, which is this one, is 6 times of X. So means by Y conducts heat 6 times much better compared to X. Okay, then I tell that the temperature of the external surface of X and Y is 55 degrees Celsius and 40 degrees Celsius respectively. So for X, if you measure the temperature, the external temperature is 55 degrees Celsius. For material Y, if you measure the external temperature, you get 40 degrees Celsius. So you don't know what's happening, what's the temperature at the joint, you are not sure, but you know the external temperature of these two materials over here. Okay, so let's try to sketch it right now instead of just showing it using these two books over here. Let's try to sketch it. Okay, so it's 4 cm multiplied by 7 cm, something like this. Okay, then it consists of 2 layers. Consists of 2 layers, you can sketch it something like this. You have 2 layers. Okay, so I'll continue to draw my line. Give me some time. Okay, so 2 layers. Oh, what am I doing? Okay, one last try. We will not spend too much time on this drawing. It's just for our own understanding. Okay, good. Fair enough. Not good. Okay. So this is 4 meter multiplied by a 7 meter. Okay, 4 meter by 7 meter wall consists of 2 material. One material is called X, one material is called Y. Then they tell that the thermal conductivity of Y, which is thermal conductivity K of Y, is 6 times of the thermal conductivity of X, 6 times of Kx. Okay, the temperature of the external surface of material X and Y are 55 and 40 degrees Celsius respectively. So this is X, its external temperature, means by if you measure from outside, which is from the left hand side, if you measure it, you are able to get a temperature of 55 degrees Celsius for the left end. Whereas the external surface of Y, which is if you measure this from this side, if you measure the temperature of Y, you are able to get a temperature of 40 degrees Celsius. Okay, so I believe you can deduce that the heat will be transferring from X along in between the wall from X to Y lah. So the heat will be going in this direction. Okay, so now determine the temperature at the boundary of the 2 layers. So where is the border in between X and Y? That is the temperature. That is the place where we want to determine the temperature. So what is the temperature over here? At constant heat flow. So the heat flow across X and Y should be the same. Heat flow is dq, rate of heat flow is dq dt. So they should have constant rate of heat flow. Dq dt should be constant for X and Y. So you should expect dq dt of X to be equal to dq dt of Y. If the thickness of material X is 3.5 cm and the thickness of material Y is 8.5 cm. Okay, so I need to label quite clearly. Okay, so X is from here to here, Y is from here to here. So if you measure over here, this will be 3.5 cm, 0.035 meter. Whereas if you measure from here to here, you get 0.085 meter. Okay, so I hope everyone is clear with all the dimensions and everything. So now if everything is clear, how do we solve it? Again, they already tell you that it's constant heat flow across the two boundary. So usually if it involves two materials joined together, right, the way to solve the problem is usually quite standard. Okay, it's quite typical question that we usually start by equating the rate of heat flow of both material. Okay, so the rate of heat flow for both material are the same, so you can say that yeah, they do not change. So dq dt for material X should be equals to the dq dt for material Y. Okay, so the rate of heat flow should be the same. Then after that, what can we say? We can say that negative K A then delta T over L. Again, we assume steady state, assume thermally insulated, so you can change the equation, simplify it. All this is for X, 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 and X. Okay, be equals to, on the other side, you have the same thing, but for Y. So KY, AY, delta T of Y, and also L of Y. Okay, so now you have reached this stage already. Let's try to substitute what we know and remove things that we know they are the same. Okay, this is the same wall, so you know that let's use these two books over here. Okay, this is the wall that we have here. We know that heat is transferring from X to Y. So let's say the white color is X, the yellow color it's Y. So heat is transferring in this direction. So if heat is transferring in this direction, that means our cross-section area will have to be perpendicular to this direction. Perpendicular means vertical, so that means by our area is the area of this wall over here. The area of this wall over here is the cross-sectional area. Okay, again, the rate of heat transfer is in this direction. The heat transfer is in this direction. So our cross-sectional area will have to be perpendicular to this direction. Perpendicular of horizontal is vertical. So this is our plane over here. This is the plane of our the plane that we use to measure our cross-sectional area. So this is the plane. Where is it? It's the base of the wall over here. Okay, so we need to find the area of the wall, and I believe you can see that for X and Y, the area of the wall, they are both the same. It's 4 meter multiplied by 7 meter. Because of that, we can actually cancel out the area of the wall for X and Y because they are the same. They are just two different layers of the same wall. So you can just remove it. Okay, how about K? We know that the K of Y is 6 times of the K of X. So we can replace KY. KY here can be replaced. KX remain, but KY here can be replaced with 6KX. Okay, then of course the minus you can remove as well. Then you are left with delta T of X minus LX, delta T of Y divided by LY. Okay, this is where the heat transfer is happening. So when we are talking about the length, you can imagine this is the length in which the heat transfer happened. So if you measure the length for X, the length for X should be 0.035 meter. Whereas the length of Y, which is from here to here, the length of Y should be 0.085 meter. Now the difference in temperature for X, the difference in temperature, always take the right minus the left. We don't know what's the temperature at the boundary over here, so it's don't know minus 55. Don't know, let's just set it as temperature of joint minus 55. So this is what happened on the material X. For material Y, the right end is 40, the left end is the temperature of the joint. So it's 40 minus temperature of the joint. 40 minus the temperature of the joint. Okay, so this is your substitution done. Again, you can see that the KX can be removed because they are the same on both left and right hand side. So if you do your calculation to calculate this thing, I believe you get an answer which is T at the joint, temperature at the joint or temperature at the boundary to be equals to 50.625 degrees Celsius. Okay, again to check whether it makes sense or not. Okay, it's not that you check this then it's confirmed to be true. No, but if it makes sense, then this temperature here should be in between 55 and 40. So 50.6 degree is between 55 and 40 degrees Celsius. So the answer sort of makes sense. Okay, so to tackle questions which involve two materials, it's usually just taking the rate of heat transfer of one material to equate it with the rate of heat transfer of another material. But one thing to be careful about when you solve this question is to make sure in what direction is the heat transfer happening. If the heat transfer is happening in this direction, then your area will have to be perpendicular to it. Then your length will have to be along the direction of heat transfer. L is along the direction of heat transfer, whereas A is perpendicular to the direction of heat transfer. Okay, if you are clear with that, then I believe you won't face any big issue in solving questions involving two materials joined in series. So that's it for this question. Thank you very much.